All right, 9-3 volume of spheres. Sphere's three-dimensional figure with all points the same distance from the center, so it is basically a ball. The radius of the sphere is the distance from the center to any point of the sphere, diameter being the distance all the way across. The formula is very similar to what we've already seen. Cylinder, pi r square h. Cone, 1/3 pi r square h. And then now sphere is 2/3 pi r square h. So, very similar formulas. We're going to jump right into examples. Should not be any more difficult than cylinders or cones. All right, correction on the formula there. I guess I should have filled this out. What this does is 2/3 times 2r. This is r squared times r, which makes that r cubed. And 2/3 times 2 makes 4/3. So our formula is 4/3 pi r cubed. So moving on, there is our formula right there. We're going to write that down. It is on the formula sheet. So B equals 4/3 pi r cubed. So a sphere has a radius of 10 centimeters. So all we need here is radius. So we're only looking for one measurement in all of our problems. So B equals 4/3 times 3.14 times 10 cubed. You punch that into our calculator. Okay, enter our calculator. 4 divided by 3 times 3.14 times times our radius, which is 10. To cube it, you're going to do the little house top and then put 3. And what I'll show you that on the calculator here. Give it just a second. I'll go ahead and put my answer up here. I've got 4,186. All right, so we'll go ahead and do it. All right, clear. Put in 4 divided by 3, just like we did on the 1/3, times 3.14 times your radius, which is 10, and then do the little rooftop right here, and then 3. That puts the cube up there and hit enter. You're 4,186.66. Back. We'll just say 0.7. That's the nearest tenth. Next problem, V equals 4/3 times 3.14. This is our diameter. This time is 3.14. We need radius, so we need to take our diameter and divide it by 2. 3.4 divided by 2 is 1.7. So that's 1.7 cubed. Type it into the calculator. 4 divided by 3 times 3.14 times 1.7, little rooftop thing, 3, and then enter. You should get 20.6 after you round. 5, 6, so that rounds to 6. And this is centimeters and meters cubed. Okay, next problem, real world. That just means word problem. Here's our formula there. Ball measures the diameter of the ball 12 inches. So B equals 4/3 times 3.14. This is diameter. Radius would be 6 cubed. Type it in. 4 divided by 3 times 3.14 times 6 cubed is 904.32. Nearest tenth would be 0.3. That is inches. It's not working. Inches cubed. All right, next problem. Find the volume of each sphere, round to the nearest tenth. V equals 4/3 times 3.14 times the radius cubed, which is 1. So that's just 4 divided by 3 times 3.14. We don't have to put the 1 cubed in there because 1 cubed is 1. 1 times anything is whatever that is. You get 4.16, which is 4.2 inches cubed. Next problem. V equals 4/3 times 3.14 times our radius cubed, which would be 10, not 20. That is diameter. 4 divided by 3 times 3.14 times 10 cubed is 4,186.7 centimeters cubed. All right, you should have the hang of doing these problems by now. We'll do one more, and then you'll move on to doing your homework. The green turtle lays eggs that are approximately spherical with an average diameter of 4.5 centimeters. Each turtle lays an average of 113 eggs at one time. Find the total number of these eggs to the nearest cubic centimeter. So we need to find the volume of one egg and then volume of all of the eggs. So this is a two-step problem. First, we're going to find the volume of the egg using the formula 4/3 times 3.14 times the radius cubed. It says diameter is 4.5. 4.5 divided by 2 is 2.25. So that is 2.25 cubed. Multiply that times 3.14 times 4 divided by 3. I just went backwards. No, excuse me, I can't do that. 2.25 cubed times 3.14 times 4 divided by 3. Don't suggest doing that because your stuff will end up in your cube or your exponent. 4 divided by 3 times 3.14 times 2.25 cubed is 47.68. We won't round yet. Now we need to multiply that times 113. So times 113, 5,388.8 centimeters cubed. Okay, should have the hang of this by now. Get started on your homework, front and back, due on Tuesday.